Welcome to Towle Talks. Today we're going to start talking about implementing our own individual characters. Now before, you're probably thinking we haven't really done much different than the previous tutorial except that we made our own lobby manager. So with the exception of that one overloaded function, everything so far has been the same, in fact exactly the same. But I thought, one, it'd be a good review, two, I thought it'd be useful for you or to see how what we're about to do. This is the main crux of what we're trying to do. Remember before we had a server, and then we had a bunch of clients, and we wanted an authoritarian server so that clients basically send commands over and ask the server to move their object on their behalf. And then the server will update stats and sync vars, and the GUI will be refreshed on the client side. So this is all fine and good, except for the issue that our clients themselves were actually the piece. If you remember, right, we talked about why this was an issue. So now what we're going to do is we are going to ask the server we're going to ask the server to make our own character separate than our network player. So now we will have our game, our server, and now we're going to have player, or our clients. And now the individual clients themselves are going to be separate from the game, or the network players are going to be separate from the game. So they're all self-contained. They're not actually involved in the game itself. This makes an interesting case. So first the client has to then call the server, the command, and ask the server to create a game object for them, a character for them to play in the game. Now, at this point, depending on how we set up, if we used is or has local authority, we could actually set authority on this character and control it directly. But since we want to use this as an authoritarian server, what we're going to have to do here is then send a command to the server like we've been doing, and then the server is going to have to remotely control this character object. Which you'll see is not nearly as difficult as it sounds, but well, it's a little bit more work here. So this is what we're going to be doing in this tutorial. Is we're going to be spawning our characters, and then controlling them. Although I don't know if we're going to get to controlling on this video. We'll probably do that next video. That's our next two objectives. All right, welcome back. So we are actually going to start making our prefabs and start making our characters. So the prefabs themselves are fairly simple. We're going to have a folder called network player down here on our assets. Make sure I'm on the right screen here. And then we're going to have prefabs and scripts. Right now I have one prefab, which I'm sorry, was not the right folder. That's network player. Players. We have a folder called players, and we're going to have three folders in there: is cube, cylinder, and sphere. We're also going to have a script object, but all three of them are going to have the same script. And then the cube, I actually made a sub prefab, but you don't actually have to for the folder. So starting off with, what we'll do is we'll just make a cube, add a cube, and I'll do this one first. And what we're going to do is we're going to say, we're going to give our player cube a canvas as a child. Now, we're not going to be able to click or anything on our cube, so we don't really care about making it have an action event or event listener or whatever. So we don't, just all we're going to do is make a label. On the canvas, we're going to have a text, and on the text, we are going to have the name, what will become the name. The trick, remember, is this is going to be a canvas. It's going to be positioned at the child 0, 0, width 100, height of 100, and scale down to match the size of the cube. If you try to do this without scaling, the text will not fit. It's important that the canvas and the name be placed on the front of the cube. So if I look at my cube, the direction Z is that needs to be the front. We're also going to do the same thing with the cylinder and the sphere. Again, if you click on them, so you go to 3D, you'll see that I have the Z-axis points toward the front for all of my objects. So the direction of my labels will be the direction that we're moving forward on. And we're going to change these texts later, but this is just for now. So once you've created this, I mean, you can pretty much duplicate the cube if you want, and then change the shapes and change names. So once we're done with this, we have to talk about the player script itself. So if I go down here, where I'm going to show you, okay, let's go down to scripts for this is for the characters now, not the network player. What we have to do here is we have to make sure that we can control these. And this is quite tricky with an authoritarian server. As I'll show you in a moment, the authoritarian server does not allow you to call commands on other objects. So really, the only object you can call a command on is your player object in an authoritarian server. This is as designed. So tragically, we are not going to be able to call commands directly on this object. So we're going to have a network behavior. This is, again, this is the character script, not the network player. This is what's going to be controlling our cube, sphere, or cylinder. And we'll have public text, my label, which, it's going to include unityengine.ui and unityengine.networking. Again, pause the video if you need to. We're going to have a public text, my label, public rigid body, my rig, and a sync var for owner. This is very important. We'll come back to this. Initially, we're just going to find our label, and we're going to do this by using a transform hack. So I'm actually going to put this script on my cube. Therefore, I'm going to have transform.getChild0, because if we remember going back over here, all children or all players have only one child, which is a canvas. And then I go back over here now. You should see that, oops, I deleted something. We will see that we have get component in children. So this is the canvas, get component in children. I'm looking for text. This will get me my text. This is useful for, again, situations that have a child with only one type of object. If you have multiple text boxes, this would not be so useful. My rig, of course, is just this .get component rigid body, and my label.text is going to equal the owner. Now, how does the owner get set, you ask? Well, we'll see that in a moment. But luckily for us, when we spawn this object, it will be on the server, and the server can set this. So we'll see what happens here in a moment. The next thing we're going to do is we're going to make just a basic command to move. In fact, this would be the exact same code you would use if you had a single player game, or something like this. I mean, you could do this in update, you can make your own function if you want, but public void move me, we're going to take a float forward and a float turn and a string O. We'll talk about what's going to happen here. Although this is probably not necessary because of the way we're setting it up. We want to verify, make sure that this is in fact owned. This object is owned by us. We wouldn't want me to take control of your character if we were playing a multiplayer game. So down here, I'm going to check to make sure my rig does not equal null. This should actually never happen, but should it happen, we don't want to have it throw an exception. And this .owner equals the O we send in, the string, the name of the player trying to make the move. If that's true, then this is only going to run on the server. And we're going to talk about why I'm not using a command here. So notice up here, this is not command. I'm using a label server, and this means it's only can run on the server. Now, what this means is my rig.velocity equals this .transform.forward times forward. I don't know why. Forward's a. I think I must have a typo there. transform forward times 2 plus a new vector, and what I'm doing here is I'm adding my y vector so I can fall down if I fall off the platform. That's all I'm doing right here. Again, this should be a review from game 1. There should be nothing tricky about this. Likewise, I do angular velocity. I set new vector 3, 0, my turn rate times 2, and 0. So I'm turning around the y-axis, so I'm rotating. So these two values will be set on the rigid body. Oh, I forgot to, we'll go back to the code or the Unity in a moment. We have to add a rigid body and do some other stuff. So these will be added to the rigid body, and the rigid body will serve as kind of a way to, well, we're going to see, we'll talk about how we're going to translate that across the network. But since this is a server, this will in fact change the rigid our velocities and such. Keep in mind, this is not a command. So currently, the player has no way of accessing this. Only the server can invoke this method. Let me double check, make sure I am. Okay, good. All right, now one thing I forgot to mention, if I click on Sphere Player, we do have to add some other stuff. And this goes for all 3 of the characters. We need to add a rigid body. And here we're going to use gravity. For networking, I use interpolate or extrapolate. You have to play around with, depending on what you're doing, which one looks better, but interpolate seemed to work better for me on this one. When you add your, you can of course add the script we just made. If I went too fast, please please pause it and rewind. Here we have character network controller. This is a thing that we made, and we don't have to worry about setting a label or setting a rigid body. We're going to do that all dynamically, including the owner. So notice it says sync var. But when you add this, you'll get your network identity. And notice we are not, I repeat, not setting this box here. The last thing we have to add is a network transform, which should be, you should have expected this because it's from the first tutorial. 9, 10, whatever your send rate is fine. Probably don't need it too big. We're going to sync on the rigid body 3D, not the transform. And the reason I'm going to do this is because we have a longer distance now between updates on the objects. So for those of you who like to move your objects with transform, this is where it's going to hurt you a little bit, because if you move it only by a transform and not a rigid body, now you're going to get discrete, jumps, and you're going to see your object jumping across the screen. Yes, it will stay synchronized, but it will not be smooth. Movement thresholds, snap thresholds can all be the same. One thing I did have to change is I had to change the interpolation factor. I had to set up to 10. Otherwise, my rotation did not work very well. Here, rotation axis is full 3D. I could actually, I think I can I could actually just do Y in this case, but we'll just do full 3D. In fact, Y would actually better be less information to send. And then what I'm going to say here is compression rate's none, and I'm going to say sync angular velocity. So I want you to think about this for a moment. One benefit of rigid body is it gives us a speed. So let's say this is my network, and I know I'm a client, and I know my object's here. I also know the speed's going forward at a fairly good pace, whatever that is. So this is my network packet. I know my object's here. I can assume the object's going to keep moving a little bit, and then when I get my next network update, I can correct my object a tiny bit. But this is a lot smoother looking than if I just, here's my network transform, boom, here's my next location, boom, here's my next location. It'll be a lot more jumpy and not as smooth. So this is why we want to use an interpolation, a rigid body with interpolation, and we want to use a network transform on the rigid body 3D. Now the same reason I want to do that for spatial translation is for rotation. If I don't have this little box checked here, it will not record the rotation, the rate of rotation, which means the rate you rotate is going to be jumpy. So here, if I can do it, I move it like, it'll look like this. And it jumps around say you have 10 times a second. So every 10th of a second, you're going to see your rotation update. And it's going to be kind of messy. If you click this option here, you'll now synchronize your rotation, and it'll look a lot smoother. You will have lag, that will be unavoidable, but this actually should not be too bad on the system. And again, if I was really worried about network volume, I could just set this to be Y, rotate on Y only. So that would actually spare me a lot of volume, or a lot of information. So that is how we're going to set it up. Once you have that set up, make sure you apply and set all your prefabs with those same properties, and then you can delete the prefabs. Next video, we're going to talk about how to actually spawn the players with our network player script. And so until then, make sure you have this working. See you next time.